What's up, everybody? In this video, I'm going to go through how to solve subarray sum equals k, which is a LeetCode problem of medium difficulty in Python. So essentially what they give you is an array of integers and a target. And what they want you to do is find the total number of continuous subarrays whose sum is equal to that number. So for this example, 1 plus 1 equals 2. And same here, 1 plus 1 equals 2. So there are two subarrays whose sum is equal to 2. For here, 1 and 2 sum to the target 3, so that's one subarray. And 3 by itself as a one-element array sums to 3. So that would be two total subarrays that sum to the target 3. So I'm going to whiteboard a little bit, and then I could show you what I had for a solution. But here, I'll go into my handy-dandy MS Paint. It's kind of cluttered because I was practicing this before. But essentially, imagine you were given these numbers as the array and this as the target, 7. So we're looking for subarrays in this array of integers that would sum to 7. So what we're going to need here for the solution is we're going to need to take into account the cumulative sum as we're going across these numbers. So for example, 3 plus 4 is 7, and then 7 plus 7 is 14, and 14 plus 2 is 16, etc. And we also would need a Python dictionary. But why don't we point out these subarrays before we get started? So I'll use a nice yellow color. So here's one, 7 by itself. We have 9. Then minus 3 is 6, plus 1 is 7. So here's 2. And that's 4. Excuse me, 1, 2, 3, 4. So that would be all of the subarrays that we would find in this array of integers. And how we do that is we would imagine your for loop and you're going across. I'm going to make our Python dictionary here. All right, so in this Python dictionary, we are always going to store, as we iterate over, the cumulative sum at the current index. So what I mean by that, let's make this. So when we start at index 1, the cumulative sum would just be equal to the first index, so 3, 1. And essentially, when we go across, we're going to say, hey, the cumulative sum, if the cumulative sum minus the target is in our dictionary, that means exists a subarray whose sum is k. And we also have to consider the amount of occurrences we've seen that cumulative sum, because I'll show you later on. This example doesn't come across where there's where you have to increment it more than once, but I'll show you later on. So we have 3 and 1, and then 7 and 1. And also, if the cumulative sum is ever equal to the target, well, then we definitely have 1. So for this one, our subarrays would already be at 1. That's terrible. Let's use this. Already at 1. I'll just make like tick marks. So we're already at 1 subarray. And now we're at here, 14. So 14 minus the target, 7. Is that in our Python dictionary? Why, yes. Yes, it is. And we've only seen it once. So we then increment our total count of subarrays. So boom, we're currently at 2. And then we'd add our cumulative sum to our dictionary. So 14. That's nice. 14, 1. Here, 16 minus 7. Is that in our Python dictionary? No, it's not, because 9 isn't in there. So it'd be 16 and 1. So 13. 13 minus 7. Is that in our Python dictionary? Well, no, it's not. So we just simply add it. 14 minus our target 7. Is that in our dictionary? Well, that equals 7. And we already have 7 in there, so we definitely increment. So we definitely increment. That's 3. And that would be this array here, this third one. And we then, actually we've already, so when we go to access the dictionary, we'd actually increment this to 2. And as we keep iterating forward, so now we're at here because we incremented this. We were there. Now 18 minus 7, 11, is that in the dictionary? Nope, it's not. So do that. And then 20 minus 7 is 13. Is that in the dictionary? Oh, heck yeah, it is. So first we would increment our count of subarrays, and then we'd add our cumulative sum, the current cumulative sum, to our Python dictionary. And that would be how you'd solve that. Now, I'm going to show you an example on why we keep these occurrences. Let's say there was one extra element in this list, right? Let's say there was a 1. 1, right? That means the cumulative sum right here would be 21. Well, 21 minus 7 is 14. And hey, when we access that key in our dictionary, it's actually 2. We should increment by 2. And the reason why is if you were to see the subarrays that would result from adding this 1, so you can see here that 6 and then 1 is 7. So I'll use like a different color. I'll use like a nice blue. So boom, this would definitely be one subarray. And then if we want another subarray, it would be from 2 over here, 2 as well. Because we have -1, and then this just cancels out, and then we have this 7 again. So the resulting would be, we'd want to increment our count by 2 here actually. So it would be, 5, 6. So if we had this array of nums, it would actually be 6. That's why we need to keep track. And then we'd store, after incrementing, we'd store, like previously, comma, 21, 1. And that would be the answer for this. And so essentially that's it pretty much. You just kind of, you're keeping track of the cumulative sums and how many occurrences you've seen them. And you're always making sure that if the cumulative sum is ever equal to your target, then you'd also increment the total number of arrays. And you're always storing that cumulative sum as you iterate along. For the answer, I'll show you guys. So we have this class. They like to do type hinting. So far on LeetCode, they've implemented this. And that kind of just specifies the output and the input types. And so, like I said, we have the count of arrays. We have the size of our list, or size of nums, so that we don't iterate over that. We have our Python dictionary. I use this from collections. I use this default dict, which basically initializes all the key value pairs to 0. So we don't have to like set it. We can just automatically, like if it doesn't exist, we just increment it by 1. So I use this default dict, and that's our dictionary for the cumulative sums and occurrences like I was talking about, and then our cumulative sum that we'll keep track of as we add. So we loop over all the items, we increase the cumulative sum obviously, and like I said, like the second element of the list was 4, I think it was, and so 3 plus 4 is 7. We'd automatically add that. Hey, that's a subarray. And then we're always checking, hey, is the cumulative sum minus the target in our dictionary? And if so, we'd increase the count by the number of occurrences for that edge case. And like I said, we're always adding the cumulative sum. And that's pretty much it. And I'll show you, this is the exact examples I was talking about. So if I were to, I have to, and Python subarray, and that's it. So you see, 14 came across twice, but we only have 4 subarrays. 14 came across twice, so when we came across 21, because 21 minus 7 was 14, we'd actually increment this 4 to 6. And that's pretty much it. This would be O of n time complexity because we only have to loop over the array once. And the space complexity would be O of n as well because we just have to store this Python dictionary in our memory in RAM. So that's pretty much it. If you like this, feel free to check out the code in the description. I'll leave a GitHub repo link to this code. You can follow me on GitHub or Twitter, and that's pretty much it. All right, peace.